All right, in this video I want to talk about factoring and finding common factors. So a factor of a number, there are numbers that show up in products that equal that number. Specifically, we're talking about we're often talking about integers, often positive natural numbers, and we're talking about positive natural numbers that groups of positive natural numbers that multiply to other positive natural numbers. For example, 10 is equal to 2 times 5. It's equal to 10 times 1. So we would say that the factors that of 10 are 1, 2, 5, and 10. Those are the numbers, the natural numbers that show up in the product of natural numbers that equal the positive natural number 10. Okay? We can do something similar with variables. We can talk about, for example, x squared is equal to x times x. So the factors of x squared are just 1, just x. Okay, x squared multiplied by y is equal to x times y. So we say that the factors of x squared times y are x and y because we have two different elements that show up in the product. Okay? Now, that explains factors. Now, let me explain factoring. Okay? So, if you had, for example, a sum of, let's say, 2 times x plus 4 times y, all right, that is equal to the following: 2 times the product x plus 2y. Now, if you can't see why those are equal, think back to the rules for distribution. Okay, so if we were to distribute the 2 into the parentheses, we would multiply each piece inside the parenthesis by 2. So we would get 2x plus 4y. See that? So notice we got back to where we started. Okay, how did I know that I needed to put the 2 in front? Because if I look at the factors of 2x and 4y, they have the 2 shows up in both of those lists. So that's why I put it out in front. All the common factors, I multiply them together, and that's what goes in front. And then what goes on the inside of the parentheses is what's left over. Okay? What's left over, in other words, if you remove the 2, like in this case, if you divide each one by 2, you'll get the x and the 2y. Okay? So let's do a few more examples. What about if we had 3x squared plus 15x? Okay, so this time if you were to list out the factors of each of the terms, 3x squared and 15x, you would see that they include the 3x squared, 3 and x, the 15x, 3, 5, and x. So 3x and 5 are common to both. All right, so excuse me, only 3 and x are common to both. So we're going to put a 3x in front. Okay, and if you divide both terms now by that common factor, that'll give you the leftovers. So 3x squared divided by 3x gives x. 15x divided by 3x gives 5. Okay, do the distribution. Distribute the 3x, and you'll see that indeed that will bring you back to where you started. Okay, so that's factoring for you. Now, let me show you some situations where you might need to factor more than once. And it might look like that you can't factor, but actually there's something that you could do. So instead of talking in generalities, let me give you an example of what I mean. All right, so suppose we had the following example. A times C plus B times D plus, let's see, plus B times C plus, let's see, did I get everything? A times, oh, and then AD. All right, so if you look over all of those four terms, they truly have nothing in common. Okay, so it would seem that we can't factor. We can't pull out a common factor and factorize this. Okay, however, not so fast. Even though they don't all have a common factor, let's pair them up in pairs where the pairs have a common factor. All right. So for example, let me take the first and third terms, okay, and let me take the second and fourth terms, and let's pair those. And if you did that, you can factor each of those. So for whatever it's worth, let's go ahead and factor each of those pairs. So the first one, we take out a common factor of C, so we get A plus B, C times A plus B. And the second one, we have a common factor of D, so we take that out, and then we have B plus A. All right. Now, of course, we can write, it doesn't matter the order that we add terms together, so we can write B plus A as A plus B. Okay. And so notice that what we ended up with is something that itself is a pair that has a common factor. So we can, and it's okay to have a factor that is a parenthesis blob, in this case a sum, A plus B. So let's factor out the binomial, as it's called, or the parenthesis blob, whatever you want to call it. And then we divide each term by that to get the leftovers. So C on the first one and D on the second one. Okay, so you'll see this situation sometimes. So the long and short of it is, you can group them into groups that they can be factored, and then sometimes when you do that, you can do a second factorization that gives you a nice compact answer. Okay, so be mindful of that possibility.